further towards the next type of gear train, that is a epicyclic gear train. So we have see the figure of epicyclic gear train. So in this gear train, there are two gear as shown in figure. So which is having the center O1 and O2. So combinedly there is a connection of arm C. So in this case, the gear B may rotate around the gear A or around the center O while rotating about the center itself O2. So when the gear A and arm C have a common axis O1 about which they can rotate, the B meshes with gear A. So B is in mesh with gear A and has its axis on arm at O2. So axis of gear B is at O2 about which gear B can rotate. If the arm is fixed, the gear train is simple and gear A can drive the gear B or vice versa. So in this case, gear A may be driver or gear may be driver. So when gear A is a driver, then gear B is a driven, and when gear B is a driver, then A become a driven. So but if gear A is fixed and the arm rotates about the axis of gear A, that is O1, then gear B is forced to rotate upon and around the gear A. Such motion is called as epicyclic, and the gear train arranged in such a manner that one or more of their member move upon and under the member as known as epicyclic gear train. Epicyclic, epi means upon and cyclic means around. The epicyclic gear train may be simple or compound. So in this case, two possibilities are there. So when arm is fixed, in that case, when the gear A is rotating and it is a driver, if it is a driver, then B is rotating about the axis O2. But when gear A is fixed, then gear B is going to rotate about the gear A or center of gear A O1 as shown in figure. So when we are going to fixing this axis, then the gear B is going to rotate like this, and such motion is called as epicyclic motion. And there are two types, one is a simple and another one is a epicyclic gear. Sorry, simple epicyclic gear and another one is a compound epicyclic gear. So the figure shown is simple epicyclic gear train, so in which there is only one gear on each shaft. So then we are going to move towards the compound epicyclic gear train. So this figure shows the compound epicyclic gear train. So in this case, two gears are mounted on a same shaft. So in this case, here there is a compound gear. So there are various members of this compound epicyclic gear train. So one is a annulus gear. So we can also call it as a ring gear, which is having internal teeth. Okay. Then this is a sun gear. The compound gear is in meshing with the sun gear as well as, so first gear is in meshing with the sun gear as well as second gear is in mesh with the annular gear. So A is the annular gear, then this D is the driver. So this is a arm H. Then this B and C combination is a compound gear. So when two gears are mounted on a same shaft, it means that compound gear is used in the epicyclic gear train. Then it is called as compound epicyclic gear train. So this is the compound epicyclic gear train. So this is the central blue one is the sun gear. Then this outer one is a ring gear or annular gear, and these are the planetary gear, or we can say the compound gear. So on a single shaft there are two gear. So one of the gear is in mesh with the sun gear and another gear is in mesh with the ring gear. So such combination is called as compound epicyclic gear